If you've been on my channel before, you've seen a previous lightning detector that I built. It was called, let's see, my channel is Electron Don 66, which you probably already figured out by now. And my previous lightning detector was a prototype system on a plug board prototype. And it's basically the same design. This is the same design as what I'd done before, but it's in an aluminum enclosure. I've also put the lightning detector on top in a plastic box. We'll talk about that in a minute. And I've added sound to this. But it is essentially the same design. And you can see that if you look for AS3935 lightning detector with TFT. So the TFT refers to the TFT display here. And this is, and it was an attempt to clean it up, put it all in an aluminum box and make it more durable, plus sound. So one of the things we'll talk about is what's the essence of this? The essence of this, there's two things. One is the lightning detector circuit, which is a SparkFun AS3935, which has a special algorithm in it for detecting lightning. I talk about that in my previous video also. Also in here, inside the box, is a Teensy 4.0 microcontroller that handles all the functions. This can detect lightning as far away as about 24 miles. I think it actually does a little better than that. You can also, there's a range select button on here too, so you can select the range, indoor versus outdoor. Outdoor has a further range. Indoor reduces the range by about a half. So let's see this work. What I've got here, because it's the middle of the winter, I have a lightning simulator. This is from Lightning Fusion. Makes it's the name of the company. It's called the SEN-39002 LG. So it's got 3 buttons on it, and these 3 buttons will simulate near, medium, and far lightning strikes. And in order to make this work, I had to cut the inductor off because it uses an Arduino controller underneath. And that controller, when it gets too close to the SparkFun lightning detector, creates radio frequency interference, which can just ruin your lightning reception. It doesn't work real well. So when I cut the inductor L2 off and placed it some distance away, that keeps the radio frequency interference from getting into the detector chip. So let's see how this works. Right now we're showing all clear. We have our legend on here, which just says lightning detector. We have a little indication here that tells us we're in outdoor mode. I also have a switch on here which can kill the sound, and the on-off switch. Oh, and when there's an event, this LED here will light up. So it's an orange LED, and we have a volume control here for adjusting the intensity of the sound. So what we're going to do here is we're going to press one of these buttons and see what happens. So that's simulating lightning. And we see it's a distance of 8 miles away. That's what it thinks it is. There's also a lightning energy indication. This is no units are associated with it. It's a relative reading of how intense the storm is. And we've also started a timer here, and the timer tells us how long ago the last lightning strike was. In this case, when I pushed the button 31 seconds ago. I have the timer right now set to about a minute and a half, and then this thing will time out and make an all clear sound. All right, when the lightning timer times out, we'll get an all clear sound. And as I mentioned before, I've got the timer count set really short for right now, so we don't have to wait 20 minutes, which is what I would normally have it set for. And this lets us know that the storm is most likely past if you do it for 20 minutes. So that's the all clear signal and sound. And if you don't like my sounds, you can put your own sounds in. They're wave files in the sound chip. We'll talk about more when we look inside. Now the other function we have is called disturbance detector. And what that will do is let you know if there's a static electricity discharge nearby. But I've also, or like a wall switch or something like that, or somebody plugging something in can sometimes create a disturber event. And that doesn't trigger the lightning detector. However, you can get lightning strikes very far away that will first show up as disturbers. Because the signal's so weak, it doesn't trigger the lightning detection algorithm. So what we're going to use here is a gas grill igniter, make a spark, and this will be interpreted as a disturber event. There we go. And if you're watching, you would see that this light here lights up to show you when an event is detected. All right, I'll just real quick here. We'll hit a lightning strike again, and you'll see that LED come on. So there we go. We triggered another lightning event, and you saw the LED work. Next, we're going to take a look at the guts of the lightning detector, what's inside the case. We talked about the spark foam lightning detector, and that's under this plastic box here. I don't have this secured down yet. That's so we could show you. I put a header on here and have a flat cable connector to enable me to connect to that. And of course, it's got to be in a plastic box so the lightning electromagnetic field can get in here. If this was a metal box, it wouldn't work. So, okay, let's take the cover off and see what we got inside. Okay, this is the TT 4.0 microcontroller. Is under this rat's nest of wires here, and I use perf boards, which allow me to connect the TT 4.0 to the perf board and then do point-to-point wiring. So this TT 4.0 talks to over this flat cable here to the front TFT display, and we have a header over here to make wiring easy. And those are the SPI bus signals. And this also comes over, the SPI signals also come over to this board here, this perf board here, which has a 74HC244 on it. And what this does is it isolates the signals between the TC and the TFT display and the flat cable here, which goes up to the SparkFun detector. So this is a buffer in between, and it keeps, when I'm talking to the TFT display constantly, this the HC244 is not selected, and it's blocking signals going up to the SparkFun detector. That keeps the SPI signals from bleeding into the detector, and this was a significant development. And that was, I also talked about that in the prototype lightning detector, which is the previous video to this. So we have our power coming in back here, quick disconnects. All these boards in here can be removed for servicing. I also have over here, well, let's talk about this first. So down here we have the Adafruit FX soundboard, and this board here has 4 wave files stored on it, and those wave files, the sounds which you heard, are triggered. There's 4 trigger signals coming over here, and each one is associated with a sound, so 0 through 4. And we have a trigger pulse that goes low for 250 milliseconds to trigger the sound. Well, there's no amplifier on this board, so we run the signals over here to this discrete amplifier board. And the discrete amplifier board is a low impedance design. It's about 100 milliwatts, and it's got a hash filter on it. All right, this keeps the noise on the 5-volt line from bleeding into the amplifier. It's low impedance signals, so when the SPI signals are flying around, they don't bleed into the amplifier. That hash filter is just a capacitor and an inductor. Now originally I had used a commonly available LM386 amplifier board, and this thing's really high impedance, and this thing was picking up all kinds of noise, and I found I couldn't use it. I had to do the discrete design instead. You don't need to put the sound in here. If you don't want it, you can eliminate this board here, which is the Adafruit FX board. You can eliminate the amplifier too, but I like the idea of having the sounds. I thought it was kind of fun. We also have the speaker back here. There's also an input power filter. This more or less keeps signals from getting out of the unit and radiating into the air. So that's basically it. We'll look at the back of the front panel. Here's our LED, which shows the event triggers, power switch down here. We have a potentiometer for controlling the sound. This is our power switch. Try to get that in focus. The power switch, which cuts power off to the audio amplifier. If the sounds are bothering you and you don't want to hear them anymore, you can just simply shut that off. And then this is our range detection switch down here, which I also talked about range detection in my original design. The SparkFun driver, it turns out, has a bug in it, and if you don't use my CPP and header files, you will never be able to select outdoor mode and get that extra range. So one of these days I gotta let SparkFun know they got a bug in their driver. That's it. If you have any questions on this, I'd be glad to answer them. It's, as you can see, it's kind of a rat's nest point-to-point wiring. I was a little worried that was going to create some interference, but by going through the aluminum case up top to the SparkFun board up here, we kind of trap a lot of the other signals down inside the case here, which keeps the sensitivity way up. Thanks for looking at my video.